I've seen that statue.
Hades is the god of them.
No, Neptune's the god of the sea.
I've been to that statue.
Yeah.
I've been to that statue, Mr. Willis.
Okay, so here's the deal. This guy is named. You been to that statue?
Yeah.
Where is it?
It's in Florence.
Oh, cool.
Oh, that's actually really.
So this guy is Urban Le Verrier. He discovered Neptune, and here's how he did it. He didn't do it visually. He's a mathematician, and him and another guy noticed that I gotta turn the lights on so you can see this a little better.
That'd be great. That'd be great. Thank you.
Him and another guy noticed that the orbit of Uranus was off a little bit. It was being perturbed a little bit by Neptune. But they didn't know Neptune was there, you see, but they noticed that as Uranus goes around, it speeds up and then slows down a little. It speeds up as it's going toward Neptune because of Neptune's gravity. And it slows down a little bit as it passes Neptune because of Neptune's gravity. So they're following this planet through the sky, and they notice that it's going along normally here, and then it speeds up a little and it slows down a little. So what they figured is there's another planet out there that's affecting it. And so they calculated where that other planet should be in the sky, and they looked for it, and they found it. So
At
mathematicians found Neptune.
At that time, at his time?
In his time.
How old, what year was that?
1800s, I think.
1846.
1846.
Good mathematicians then.
They were good at math. Of course, Newton was one of the best mathematicians.
So
He was before that. But anyway, that's a cool way of finding a planet, and keep that in mind because it's also how they found Pluto, which we're going to talk about. But the story there is a little bit different. Anyway, so this is Neptune, and that's what it looks like if you had it next to the Earth. It's about the same size as Uranus. It's about 4 times as big as the Earth. It's a little darker blue, and that's because it's got a little more methane.
Oh yeah.
More methane in the atmosphere makes it bluer. It takes 16 hours to rotate once. What was Uranus's rotation?
Hours.
10
hours. 16 hours.
14.
12 hours?
I don't know.
I think it was
16.
I thought y'all knew.
Wait, what was the question?
So Neptune takes 16 hours to rotate once. What did Uranus take?
To rotate once?
Yeah. It was in the last chapter.
It's
80.
I want to ask you.
That's 16 and a half, maybe?
16 and a half hours.
No, I mean like what type of gases?
Around the sun.
Oh, 16.5.
Yeah, 16 and a half. So it's about the same as Uranus
Trying to make it
It's
a
right
quick.
here.
Yes,
as far as how long it takes to go around. Are y'all with me here?
sir. We was talking about the gases in your ring.
It is a gas giant, just like Uranus. It has about the same percentage hydrogen and helium, just like Uranus.
Also,
It's very similar. Uranus and Neptune are almost twins.
okay.
Since it's farther out than Uranus, it takes 165 years to go around the sun once.
Sheesh.
So no human has ever lived a Uranus year, a Neptune year. Yeah.
Does
2 years
Neptune have that big storm like in the bottom, right where that eye is right there? Is that like a big storm?
Yeah, it's a storm, and Neptune has had storms come and go on Neptune the same way as they do on Jupiter. Look at that big storm right there. But they seem to not last as long as they do on Neptune. On Jupiter. They've had storms that go out after a few years instead of lasting for hundreds of years.
I forgot my question just that fast.
Just like Uranus, Neptune has a magnetic field that's different than its axial tilt. So the axial tilt is 28 degrees, which is kind of like Earth. Earth is what again?
27.5.
Earth?
23.5.
Earth is 23.5, and Neptune's 28. So it's a little more than the Earth. But the magnetic field is way off
Which one
from
was
the
27?
tilt. 27 is Saturn. So the magnetic field is just like Uranus has a 47 degree difference. Uranus was, I think, was 59 degree difference. Either way, it's a big difference between the magnetic axis and the rotational axis. And again, scientists don't, just like with Uranus, scientists don't really understand why the difference there. There's something off in the middle of these planets. Maybe something about these, they call Uranus and Neptune, they call them ice giants. Because they're so cold that the gas, as you go deep into the planet, the gas turns to slush and ice as it gets more dense. And so they think that deep below the surface, as you get into maybe a third of the way into the planet, that there's a bunch of ice. And so they call them ice giants. It's kind of a weird situation.
I understand why it's cold, but why is it mysterious? Is one of the things it said on that little wrap thing they had. It's like next thing I'm cold and mysterious.
Oh,
Why is it mysterious?
I don't know why it's
How
mysterious.
did you remember that?
You weren't there when we had to do
I
it.
guess
You
you have to
missed
play
it.
We should
No,
play that for you.
I
I'll play
heard
that
it.
for you at the end here. Remind us at the end. We'll
I
have
thought I heard it when it was all the planets, right?
Yeah.
I was here.
You were here for that?
Yeah.
No, can we play it anyway?
I asked him how
No,
did he.
you weren't here.
I asked him how did he remember that.
Maybe it's
No.
mysterious because they don't know why the magnetic field is off from the axis. That's kind of mysterious. This storm right here was seen when Voyager went by Neptune in 1986. They had this big storm here. They called it the Great Dark Spot.
That's what I had to ask about.
Then, the next time they could look closely at the planet was when they launched the Hubble Space Telescope. And that thing looked back at the planet, and the storm was gone. So we know the storm lasted, was there in 86 and gone in 94. So they don't think storms last that long on Neptune.
Okay, so is it all just like gas? There's no type of liquid in that?
Well, well, it depends how deep you go. So it starts as gas, and then if you take gas and you compress it real tightly, it becomes liquid. And then if you take liquid and you compress it real tightly, it becomes solid. So as you go deep down in the planet, these gases become compressed by gravity and all the other gases that are on top pushing down. And so you do, in all of these gas giants, you go from gas to liquid to solid. And the very core of these things are solid. And outside of that, it's liquid, but most of it is gas. Most of these gas giants are gas.
All right.
So, the white clouds you see are methane clouds. That's just clouds of methane, and they're nice and white there. And we see these clouds. You can follow these clouds racing around Neptune and see the rate they moved. And they've calculated that the winds on Neptune, if you could stand at the surface of Neptune, even though there's no surface, if you could stand on some platform or something like that, you would feel the winds coming by at 1,200 miles per hour.
Wouldn't that like rip
So
us?
it's real windy.
Wouldn't
Yeah,
that like rip your skin off?
It would knock you over. Yeah. It's just like that's faster than a tornado wind. So
Would
yeah,
that put you in orbit?
that would get you. Probably just tear you in a little pieces.
Oh my god. Wait, can tornadoes do that?
Yeah.
Does that happen to people?
Yeah.
It just rips them apart?
Yeah.
No.
You haven't ever seen
Tornadoes?
Yeah.
No.
You never seen it?
Usually, like, will just throw you
To
away.
not get put in
So
If you were somehow stuck there and the wind was going, it would probably rip you apart.
Just the winds by themselves.
Yeah.
I don't believe that for some reason.
Try it.
Have you not? If they can rip like cars and houses to pieces, you don't think you can rip your body?
Too strong for
What
that.
else? 55 Kelvin. Listen.
Hard body.
55 Kelvin is the temperature at the top of the clouds, which is really cold. This room right now is about 300 Kelvin. So you're talking about 250 degrees Celsius below the temperature of this room. So it's really cold. So the only planet in the solar system that's colder is Uranus, which actually has a 48 Kelvin cloud temperature. For some reason, Neptune has more internal heat than Uranus has. And they think probably inside Neptune is a bunch of radioactive substances that are producing some heat.
Okay.
And that probably comes from deep down within the planet that heats the planet up a little bit hotter than Uranus. Here's what it looks like if you could go down into Neptune. There's gas up here, and then as you go down, this is all gas. So most of the planet is gas.
Okay.
And then once you get down into this area of the mantle, that's the ices that I'm talking about. Water ice, ammonia ice, methane ice. That's why it's called an ice giant, because there's these like ices floating around in a kind of a liquid, kind of like a milkshake is what this is like right here, of these ices floating around. And then you get deep enough, and in the very center is a rocky core made of rock and ice and some heavy metals. And that core there might be half the size of the Earth, something like that. So that's Neptune, and Uranus is pretty much the same way. So Uranus and Neptune very very similar. Neptune also has rings like Uranus. I think it's got 5 rings. I'm not positive on that, but that's what I'm thinking.
It says it's 5.
Does it say 5? Okay. So there you see some of them. They've blocked out the light that's coming off the planet, so you can see these faint rings. They're real faint. They're not like Saturn's rings. You can barely see them. You have to have perfect conditions.
Is this a real picture?
Yeah, that's a real photo. I think that's. I don't know if that's taken by a spacecraft going by or taken by the Hubble Space Telescope or something. Could be from a spacecraft. There's only one spacecraft that's ever gone by Neptune. You know what it was?
Voyager 2.
Voyager 2.
Oh, shoot. Yeah.
Voyager 2.
How long
That's
did
the
it-
only one that's ever been there.
What happened to Voyager
How long did it
1?
take?
Voyager 1 went past Saturn, and they wanted to steer it toward Titan to see that moon. And once they did that, it was off. It couldn't go see the other two gas giants. It couldn't go see.
So it's just floating somewhere?
So it's just flying off into space. It went past Titan, took a bunch of pictures, and now it's just flying off into space.
Bye-bye.
And Voyager 2 kept on going and saw Uranus and Neptune.
Is it going in a straight line? What if that like came back and hit Earth?
It doesn't have any gas left, so it's just going. It's just coasting. What if it what?
Like fell into another planet?
It could, but there's so few things. Remember when we did our thing in the solar system? Those little BBs. That was the only thing there. Everything else is empty space. So the odds of hitting something are almost nothing.
Right.
You're just floating on forever. Wow, pretty cool. Now, Neptune does have a big, cool moon that is very active, and believe it or not, it's not active because of the tidal heating, but it's active because it's at a temperature. This moon is one of the coldest bodies they've ever studied in the solar system.
Wow.
And it's so cold that nitrogen gas freezes into liquid and solid nitrogen. Have you ever heard of liquid nitrogen? It's real cold.
Yeah.
You put a rose into it, you can break the rose. I mean, this stuff's real cold, and so it's Triton is so cold that it becomes solid nitrogen, like nitrogen snow. And this solid nitrogen settles into the craters on Triton. And whenever the moon turns so that the sunlight goes down into a crater, even though it's so far from the sun, that little bit of sunlight will heat that nitrogen up a few degrees, and the nitrogen just expands like crazy. It goes from solid to gas and expands and comes shooting out of these craters. And so you get all this activity. They're called nitrogen geysers, and you can see them on the surface. You see that black right there? That's black nitrogen smoke coming out of one of these geysers, and there's a bunch of them. You see that? And there's they look like these black kind of scars on the planet. And they actually have several pictures of this, so you can see it kind of in film. You can see this smoke coming out of these craters. It's really cool.
Is it smoother up on like?
Yeah, that looks. I don't know why that's smooth and that's not. I don't know. Somebody probably knows. This is a newer. I would guess that this looks heavily cratered and this does not. So this might be a newer surface. Maybe there was some stuff that got spread out, lava or something early in the formation. I don't know. That's a good question.
So it sprays what?
Nitrogen gas comes shooting out of these craters, and it's not just nitrogen gas. It pulls pieces of dust and rock and stuff up with it, and so you get. There's a lot of pressure there, so it's kind of like explosions happening on the surface every time the sun hits it right. Triton's also different because it's a retrograde orbit. It's going opposite the way the planet's rotating. So Neptune's rotating like this, and Triton's going around the other way. So Triton's going around this way. And because Triton has this retrograde orbit, they think it's probably a captured asteroid from the Kuiper Belt, which is just a little bit further out than Neptune. There's all these asteroids and comets, big balls of ice, that sometimes get knocked off their orbit and come in and can get captured. And another cool thing about Triton is it's falling in toward Neptune. It's slowly, every year, it gets a little closer to Neptune. And they've calculated that in 100 million years, it'll be pulled apart by tidal forces, and Neptune will have these big rings, way brighter, way bigger than Saturn's rings, because Triton is a really big moon. And so when that happens, you'll be able to see Neptune with the naked eye. Right now, it's too far away and too faint to see with the naked eye. But when it has these huge rings that reflect a lot of light from the sun, you'll be able to see it. And that's only 100 million years away.
Won't the Earth be like eaten by the sun by then?
Nope. Earth not eaten by the sun for 5 billion years.
I was trying to hit it.
So 100 million years is nothing compared to 5 billion years. 1/50th.
You don't say that at all.
Would you feel it at all? Like
Feel what?
on Earth, like it's smashing into
No.
Neptune?
That's way too. It's way
Way
too
too far.
Yeah. In our little model that we did outside, where the sun was, Neptune was up by Officer Lacey's house.
Yeah.
Remember that?
Yeah.
So
It's a long way away.
way far away, and it's a marble size. It's like a marble at Officer Lacey's house. So a little BB falling into marble at Officer Lacey's house isn't going to affect us here.
So I don't.
Is the sun swallowing the Earth the quickest thing that's going to destroy the Earth?
Or meteor.
The sun is not.
A meteor hit. What were you going to ask, Santana?
Anyways, it's not. How could we be able to see Uranus if it's so far? Not Uranus, but Neptune if it's so far away.
Well, we can't see it right now.
I'm saying when.
Oh, well, telescopes. Now, telescopes you can see it with. But I'm saying with the naked eye, you'll be able to see, it'll look like a star with the naked eye when it has these big rings. Right now, it's too faint to see with the naked eye.
You said that's the coldest body? It's the colder than Neptune?
Yes, this is, I think they measured this at 34K. And the top of Neptune's clouds is 55K. So Neptune a bit warmer than Triton. You want to see video of Triton?
Yeah.
Yeah, I do.
Heck yeah.
Heck yeah.
This is one of these cool videos.
Neptune.
I love these videos.
60 times larger than Earth. Like the other gas giant planets, Neptune has no surface to even land on. If we want a place to explore, we'll need to look to the moons. Here, nearly 3 billion miles away from Earth, is the coldest moon ever recorded. At almost minus 400 degrees Fahrenheit, it approaches absolute zero, the temperature where all movement stops. If any moon should be a frozen ice ball, it is this one. Yet in Instead, it is the world in full motion. Dynamic. Active. One might even say psychedelic. Welcome to Triton.
Triton is the largest moon of planet Neptune, on the very distant fringe of the solar system, with its extreme conditions, exotic composition, and bizarre geologic processes. Triton is an absolutely surreal
Why is he hiding?
On the coldest moon in the solar system, there are geysers, volcanoes. The frozen surface is alive.
It has one of the most dramatic displays of volcanic terrains in the solar system, which sounds surprising perhaps because icefall, volcanism, they don't seem to go together. But in fact, Triton's form of volcanism involves molten ices.
Here on Triton are the first ice volcanoes ever found. The volcanoes start deep underground, where Triton's weak internal heat turns ice into liquid. Less dense, the liquid rises to the surface, creating an explosive eruption that showers the moon not with melted earth, but with melted ice. The cold, slushy lava forms an utterly fantastic ice-sculpted landscape.
How cold would that ice be?
Real cool.
Even more surreal than volcanoes
38
made of ice.
Kelvin.
Oh, God.
Triton's powerful geysers. On Earth, geysers are made of boiling water. On Triton, geysers are made of boiling nitrogen. As bizarre as it seems, with nitrogen, you can have a boil at 320 degrees below zero. So cold, everything familiar to us shatters like glass. And yet so volatile, they produce the highest geysers the solar system has ever seen.
I really would, man.
Standing on Triton, we would want a pressurized and heated spacesuit given the conditions there. If you were dumb enough to go out of your spacecraft on Triton without a spacesuit, your head would explode in about 3 seconds flat, and then you would freeze to 390 degrees below zero. Your body would be hard as steel. Standing on the surface, we would experience 1/12 of Earth's surface gravity, so we would feel very light and buoyant. We'd be able to jump 12 times higher, for instance, than we would on Earth.
And for the truly brave, a new sport, geyser diving.
It might be very interesting to go down into the holes if you dare. There'd be all sorts of reverberations with supersonic gas rushing out. We may end up in a pool of liquid nitrogen, boiling fervently.
As nitrogen boils, it produces a vapor that expands hundreds, even thousands of times in volume. Intense pressure builds, so the geyser finally gives. The explosive force shoots 10 times faster than any geyser on Earth. When it reaches 5 miles high, about the height of Mount Everest, the geyser, darkened by carbon, is sheared at a right angle by Triton's high altitude winds. If you didn't know better, you'd think this moon had smokestacks. Once scientists assumed the outer moon would be cold, dead, and boring. Now we know that even 3 billion miles from the sun, in the shadow of Neptune,
You're not on
we
Triton.
can have a startlingly beautiful world in motion.
Yeah.
And if the coldest moon can be this active, just imagine what the other moons have to offer.
Holy shnikes.
Can I go?
Wanna go? Okay, last video. on Neptune. Space school.
Neptune, the 8th and furthest planet from the Sun, 17 times the mass of Earth, and nearly 2.7 billion miles away. So far away that 5 of its moons were not even discovered until the 21st century. Will we ever manage to visit this distant, ice-cold, cobalt blue world? Welcome to Space School. First observed by Galileo in 1612, he mistook the planet for a star. Neptune wasn't officially discovered until 1846. Oddly, it was not found using a telescope, but instead by mathematical prediction. Irregularities were noted in the orbit of neighboring Uranus. Calculating the discrepancies in Uranus's path, French mathematician Urbain Le Verrier predicted the exact point in the sky where a planet should be. Astronomers trained their telescopes on its spot, and there it was, just 1 degree off from where Le Verrier had predicted. The 8th planet, the last planet in our solar system, was soon named for the Roman god of the sea, Neptune. If Neptune was hollow, it could contain nearly 60 Earths. One of the 4 gaseous outer planets, Neptune is almost identical to Uranus in structure and composition. Like Uranus, Neptune is considered both a gas giant and an ice giant. The planet has thick layers of ice and gas, surrounding a small, solid, rocky core made up of iron, nickel, and silicates. The temperature at the very center of Neptune is estimated to be over 9,000 degrees Fahrenheit. Neptune, like the other 3 gas giants, Saturn, Jupiter, and Uranus, has no solid surface. Only an atmosphere, giving way to a superheated liquid mantle. It takes Neptune almost 165 Earth years to orbit the Sun. Neptune's atmosphere is composed of 80% hydrogen and 19% helium, along with traces of methane. That methane absorbs red light, giving the planet its blue appearance. The weather on Neptune is extremely dynamic, with multiple layers of clouds constantly moving at high speeds. Huge storms are commonplace, with winds reaching well above supersonic speeds, nearly Mach 2. Neptune, in fact, clocks the fastest winds in the entire solar system. These incredible wind speeds are thought to be the result of heat rising from the planet itself. The Sun simply doesn't provide enough energy to explain these powerful storms. But the Sun, despite its distance from the planet, still does impact the climate of Neptune, mainly by creating 4 distinct seasons. And with a year that's 165 Earth years long, just one of those seasons can last 4 decades. Neptune has 13 known moons, but one of them, Triton, is the largest by far. It contains more than 99.5% of the mass of all the bodies in orbit around the planet. The massive Triton, unlike most moons, moves in a retrograde orbit, the opposite direction of the planet's rotation. Most likely it was once a dwarf planet, but was pulled into Neptune's gravity. Triton's surface is composed of frozen nitrogen, water, and frozen carbon dioxide, dry ice, as well as other trace elements. It is also one of the few moons in the solar system that is geologically active. Dotted with geysers, it is believed to erupt nitrogen. Triton also has the coldest surface temperatures in the entire solar system, dipping to a staggering minus 400 degrees Fahrenheit. Today, Neptune already has 4 rings, but they are narrow and faint. So faint that they weren't even discovered until 1968. They are believed to be made up of dust particles, the remains of meteorites that long ago smashed into Neptune's moons. They are so unstable that one of them may disappear in as little as a century. The rings of Neptune were once thought to be incomplete arcs. A flyby of the planet in 1989 showed them to be complete. Neptune is the least explored of any planet. It has only been visited by 1 spacecraft, Voyager 2, in 1989. But that single mission discovered a new ring, 6 new moons, and answered many questions about the weather on this faraway world. It also flew by the moon Triton, sending back valuable photos and data. There are currently plans on the books to launch the Neptune Orbiter, a satellite that would circle the planet for 3 to 5 years. But this spacecraft, which would take 8 to 12 years just to reach Neptune, isn't even scheduled to launch until at the earliest 2016. Until then, this distant world will remain, in many ways, one of the solar system's biggest mysteries. This is Space School, signing off. Class dismissed.
Can you answer that question?
It says at the earliest 2016. What year was that movie made?
That makes old. Space School, those are old. What's that?
You know that song now?
Alright.
Oh!
Yeah.
Nice, Jack.
The solar system song
I'm tired.
for
Rap.
Kids.
Not that one. That's not it.
That's not it?
No.
No.
Keep going. That's it right there.
This one.
Yeah.
Yeah, the one above that too is good.
Yeah.
We can see the whole solar system from here. I think we can hear it from here too. We are planets, solar system, different sizes for everyone. Music never ends, we are such good friends, and we all orbit the sun. Here comes the sun, rapping first on this track from the beginning. I'm the center of the solar system, planet keeps spinning around me. So hot, I'm roasting, you see. Now I pass the mic to the planet closest to me. Mercury, the smallest planet, small as Earth's moon. I get too hot and cold, and it's been very slow. Venus, I got mountains and volcanoes and spray. I'm the same size as Earth, and the such a beautiful, beautiful world. On Mars, a red planet. I got deserts and ice, and I got two moons. That's like one moon twice. I'm the biggest planet. I'm humongous, gargantuan. I spin the fastest, record fastest, plus I'm handsome, glimpse. Oh, please, I'm Saturn. Check out my beautiful rings, made up of billions of rocks, dust, and other things.
I'm Uranus. I say that with pride. Okay, I lied. I'm Embarrassed because I'm the only planet lying on its side.
I'm Neptune. Cold, dark, windy, and mysterious. I'm very stormy, so bring an umbrella. I'm serious. Solar system, different sizes for everyone. Crazy never ends. We are such good friends, and we all orbit the sun. Well, we are done exploring the solar system. I am thirsty. Let's explore the rest of the Milky Way galaxy.
And we all orbit the sun.
And that's good time to do that because we're done with all the planets.
Are we not going to do the dwarf planet?
We're going to do the, next we go to KBOs and Kuiper Belt objects and get further and further out, and then we start on stars and learn about the sun and the Milky Way and galaxies. So it gets bigger and bigger.
And the Mr. Willis class for today.
Peace out.